Hey, YouTubers, Tazman here, bringing you another episode of Taz Teaches Programming Logic. And believe it or not, we're actually getting really close to the end of the actual programming logic, because after a certain point, all you run into is the syntax. And so we're kind of getting to the end, but we're going to do a little bit more today, and then we're also going to maybe give you a challenge at the end. So we're going to learn some new cool things today. So let's see. So what we've talked about so far, and we kind of want to focus today on our flow charting, just so you can understand it. So we've talked about how this symbol right here. What does this one mean? Let's see if you can get it. We'll give you just a second. Okay. So if you haven't got it yet, or if you have, this is the start or the stop or the end, STOP, of your program, right? After that, we have one that kind of looks like this. Sorry about how straight everything is. And what's this one? This is your I/O, your input and output. So when you're getting things from the user or outputting to the user, usually you'll put them in this type of thing. All right, the next one is so this is your processing. This is where you're adding numbers together, or you're uh, subtracting, dividing, multiplying, whatever. You're doing something, you're processing information. So it could be the stuff you got from an input, you're adding two numbers together, you're doing stuff like that. Then after that, we had one that looked like this. And that is your decision, right? So this is for decision making, which can end up being your if type statements, if, slash, and your loops, right? And let's see, what else did we talk about? I don't know that we actually talked about much more than that. There are a couple more that I would like to point out, because sometimes when you're flow charting, you might hit the bottom of your page and you want to go to a new page. So there's actually one that kind of looks like this. It kind of like has an arc on the top and then goes down, and then it goes like that. And this is, I think it's called the end page or something. Now these things might have changed, but because this is pseudocode, whoa, what the? I don't know what I did. Hit Control Z. I was wiping off my. Hello, Control Z. No, it won't change my page back. Great. I did a rotation. Let me see if I can fix that real quick. Can I click on here? I have no idea how I rotated it. Let's just go to free transform. Oh no, I don't want to do it to that. Control Z. Help me. How to fix that? Maybe I rotate it here? No, that zooms. I done broke it. One more. Well, something like that. Poop. All right, hold on a second. I'm going to see if I can fix it real quick. Okay, we're back. So anyway, this is what it kind of looks like. It kind of looks like it has a curve on the top and then straight sides and then kind of down to a point. And then usually there's a number inside, or you could use a letter, whatever you want. And this is called the, what was it called? Like end page or something? Or next page. We're just going to call it next page. I can't remember the actual term. And then, so this guy is more of an oval. Then we have just a little tiny circle with a number in it. And this is, I don't know, maybe page continue. So that's our page continue. So you have this guy saying, oh, you need to go to number 5, and then this would have number 5, and that means at the very top it would have a number 5. So we'd have our stuff here, blah, 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 and then we'd have our little thing here, like this, saying 5. Then at the beginning, instead of having another start, we would just put a circle with 5 and continue our code there. And that just helps you get from page to page. And then another one that's kind of important that we're going to talk about today is called this guy. And it looks kind of like the process, but usually there's a name in here. Right? This is a condition. This is like A plus B. And this is hello. Right? That's an output. And then this is start. Okay. So anyway, this one is called a subroutine, is what it was originally called. So we have depending on the programming language, routine. So subroutine, it's also known as a function. It's also known, it's also known as a method, and so forth. And I think that might be, actually let's say or function. And I'll explain this in just a minute. So basically we have these things, and there's actually quite a few more. There's one that kind of looks like a little disk like this, which represents, you know, like a data source, a database. It could be hard drive, it could be something like that. DATASOUCESOURCE. So data source, database, something like that. So these are the ones that we're going to focus on, maybe not so much the data source one, but I just want to point out there's actually quite a bit more. So let's go ahead, and what we want to do is kind of focus in on that subroutine one, because it actually becomes very, very important and very, very useful. So let's say, for example, we're making a game like Risk, or, you know, just a game like that. So first thing you do is, you know, you get out all your pieces, you set them up, and then usually you will roll a dice to see who goes first, right? And then you have your different phases. You know, you play, you place your guys, PLAC, place men and women. We'll say women, because we are an equal opportunity tutorial. So you place your guys, your men, women, whatever, and then you do an attack phase, right? Attack phase. And in the attack phase, you roll the die. And then you evaluate who dies, right? You say, oh, so-and-so died. How should we say this? Evaluate. EVALUA. Evaluate casualties. I don't know how to spell casualties, so deaths. I probably could spell casualties, but while trying to do this, and then you do your, let's see, what is it? So you place your people, you do the attack, then you end your turn, or first before that you can do, I'm just going to call it the free move, where you can reinforcement phase. That's what I wanted to write. so the free move. And after that, we do the end turn. So as you can see here, we're doing a couple things at least twice. So we're actually rolling the dice up here, and we're rolling the dice up here, or down here. So in our program, we would have to write almost the identical code here and here, because there's no way we could actually reutilize this chunk of code that's actually in the program where we're seeing who goes first and use it for what we do down here. And this is where subroutines come in. So in early programming, your entire program was kind of considered a routine. It starts at the beginning and it goes through the things from step to step to step to step until it hits the bottom, and that's the whole routine. Well, a subroutine is to say, oh wait, you know what? I'm going to separate this guy because this is duplicate code. We're going to separate this guy and this guy into kind of its own program, except for it's not quite as advanced as that. But then what we do is we would use our start-stop thing in our flowchart, and we would create, instead of start here, we would call this roll dice. And then we would come here and we'd have a process to, roll 6-sided dice. And then it would end. And we'd put return. So now what happens when we do our game is we can just simply call this, it does its thing, and then it returns back to the program, the main program. When it gets here, it calls this, and when it's done, it knows to return back to where it launched from. So this is why we have subroutines, so we can separate these things and not have to write duplicate code. Not only that, let's say, for example, that we wanted to change it. It's a different game now, but we wanted to change it so you're no longer rolling a 6-sided dice, you're rolling a, let's say, 12-sided dice, right? Well, if I didn't have the little subroutine, I would have to go through every piece of my code and find anywhere that I had 6-sided dice. So if this said 6-sided in its code, I would have to go change it everywhere in my code. Whereas if I have it go to the subroutine here, I only have to change it here, and everywhere throughout the program is automatically going to update. Now with subroutines, unlike, well, actually that's not accurate. So some programs, you might have launched a program and it says, launch this, like Minecraft, for example, you can launch with arguments. So, you can launch Minecraft with the Java arguments saying how much memory you want to use, or where the Java engine you want to use is, and such like that. Those are called arguments or parameters. Well, we can actually pass parameters to this. So for example, let's say we wanted to leave this, so we're not actually specifying how many sides our dice is. So we could actually, in our program, we initialize an area saying the number of sides, right? And then when it hits here, we can actually say, hey, we're going to pass to the program, we're going to actually pass a 12-sided dice, where here maybe it's going to be a 6-sided dice. And then the program will receive that 6 or 12, and it will place it in a variable within the code itself, saying, okay, I'm rolling a 6-sided dice. So we can actually pass variables and we can receive variables. Obviously, if we're rolling dice and it rolls out here, we need to return that. So we could say return roll, right? Or return results or whatever. And that will return here the simple number saying, hey, you rolled a 3. So if you don't understand this, we're going to kind of really go into this a lot. And what I wanted to do is maybe, should we just launch? Let's do it. Let's pull up our Eclipse real quick, and we'll give a quick example. So here's our Eclipse. Like I said, we're gonna go into installing Eclipse. It's actually really easy. It's not even an actual install, But is that how far I want to go? Yes. Okay, so for example, when we start in Java, when we start our program, we're going to leave that up there. No, actually, we're not. I was messing around. So as you can see here, this is the name of our function, our routine, our method, or whatever. So when a program starts, it looks for the main function, method, subroutine, however you want to call it, depending on what language. In Java, it's called a method. So it's going to look for main, and then this is saying these are things that I'm going to receive. So when I launch my prog_structure.java here, or prog, when it's compiled, it's called prog_structure.class. When I run it, I can actually pass it variables. I could say, I could launch it with prog_structure space Troy, or John, or Mark, or any name I want, and that will be passed into this string args. And this is the data type. It's a as you can see, the brackets here mean that it's an array, and the string is the type, but the arg is the variable that we're passing it in. So later on, if we come in here and we say, hey, what's in arg, we can actually get it to say Troy, John, or Mark, And then this one right in front of the name of our method, this one is what it returns. It's returning a void, which means it doesn't return anything. However, we could say return an integer, and that means when this is done running, it would return to the calling procedure, or whatever, the calling method. It would return whatever we're telling it to return. So let's just go into this just a little bit. So we're gonna just do a quick little die roll. So the first thing we're gonna have to do to make a die roller is we need something to generate a random number. Now there really is no true random number in computers because it uses time seed generally. Now you can do something to, can augment it or whatever. We're not going to worry too much about it. We're just rolling a dice. Who cares? It's not like the picking lottery numbers or something where you don't want someone to figure out your exact algorithm you're using to generate the number so that they could figure out exactly what number it's going to generate. But what we want to do is we're going to create a new object. And the way you do that in Java, and we're going to talk about objects in just a little while, but objects have a little less to do with your programming logic and has more to do with an actual language like C++ or C# or Java and so on and so forth. So what we're going to do is we're going to go ahead and this is how we generate a random number. So we say random like that, and then we come up, so this is the data type is random, and our data type is going to be, let's say, my num. So what we're going to do, first we're going to do this without a subroutine, just so you can kind of get an idea of how it works. So we're going to do my num is that, and then we're going to say equals, and this is going to create a new object of my num. So it's not random is not just a single variable like an integer that only holds a number. Random actually can hold a lot more. It's its own kind of little program, which, like I said, we'll go over later. So we're going to say RANDOM, so we have random, and then we do that, and there we go. So now you'll see we have a red underline under it, and this is because we need to import the random package, or the random, I think it's called a package in Java. So as you can see, one of our options here is import random from Java util. Now we could actually come up here and type import space java .util.random and then a semicolon, and then this would go away. But this is actually just a quick little way. It's going to do that for us. So as you can see, import java util random, and now this is happy. Now the reason this has a little yellow squiggly under it, if you mouse over it, it says this variable is not used. So let's use it. Actually, let's change this. This isn't going to be my num because this is the class. We're going to call it RND for random. So now if we want to call it, we can say int, right? So we're going to actually have an integer now, and we're going to call this one my num, and we're going to say equals, and we're going to do rnd, and then a dot, because this is calling one of the subroutines or subclasses in there, and we're going to call it next int, because we want the next int. And this is the range. So if we want 1 through 10, then we would say 10. But we're going to try maybe 100. Okay? And then we're going to do SOUT, or actually it's probably better to show you this, SYSTEM system dot out dot println for print line, and then we're going to do my num. And there's our thing. So if we run this now and save it, you'll see we got the number 97. If we run it again, we get 41. And run it again, we get 4. So as you can see, it's generating a pseudo-random number. Now, if I knew exactly what the time seed was that it is using, then I could actually predict this number. If I knew exactly what the time seed was when I clicked play, I could actually predict this number and seem like I'm clairvoyant or something. So as you can see, we now have a random number generator. So how would we use this? Let's say we want a 6-sided dice, right? So we just say 6. And there we go. Now we have a 6-sided dice roller. So there's 2, 5, 5, 0. Although look, we have a 0 in there. So this isn't actually generating a number between 1 and 6. It's actually generating a number between 0 and 5. So it's 6 digits. So what we need to do to counter that is add a +1 to the end. That way, if the number we get is 0, it'll be 1, and if it's 5, we get the 6. So now we'll actually be able to see us get some numbers that are like 6, right? And we should see maybe a 1. There's a 1 right there, another 1. So right there, we've now got something that generates a number for us. Now, let's say we do want this to be dynamic. We could actually replace this number 6 with, let's replace it with something called how many sides. How many sides does the dice have? Now you see it instantly turns white with a red squiggly under it because we've never defined anything called how many sides. So if we come up here and say int and say how many, and we should be able to hit that. If we hit control space, it should auto-complete or at least give suggestions. So if we do that, we've now declared how many sides, but we've never initialized it. So this is still going to error out because we've never told it how many sides. Right now, this is just a variable that has nothing in it. In different languages, it has actual garbage in it because it's just pointing to a chunk of memory that was already there. It wasn't cleansed. It's just memory sitting there. So we have how many sides, but we want to say how many sides of a dice do we want to use. So let's say we want, the little triangle dice from role-playing games. We want a 4-sided dice. All right? We hit run on that now, and we get a 4-sided die. So if I want to do this in a program, and this is actually really simple, but anytime I want to roll my dice, I would need to redeclare how many sides, and I would need to do that guy right there. So I'd have to stick the same chunk of code. Well, if I don't want to do that, what I can do is outside of this one right here, as you can see, it highlights that. This is our method of main. We want to create our own method, and we're going to call this public, and it's going to return an integer, int, and we'll call this roll dice. And then this is going to expect us to pass something to it because we want it to be dynamic. We want to be able to change in our program at any time. Say, I want to roll a 6-sided dice. I want to roll a 4-sided dice. I want to roll 20-sided dice. And we want it to act accordingly. So what we do is, as you can see, this is the block of code signified by the open curly brace and the closed curly brace. Everything with, oh, whoops, this is the wrong one. This is the main. This is our actual program itself. This is the main that launches. This is the code block signified by the open curly brace, closed curly brace. So this guy is going to receive something called int sides. And then we're going to go ahead and do that. And then all we have to do is now we can leave our int how many sides. In fact, we don't even need this because we're, well, no, we don't even need that because we're actually going to declare our sides right here, right? So what we want to do is then take in this piece right here, Control X, we're going to paste it in here, and we're going to return RETURN, because this is what we're going to return is whatever value's in here. And now, because how many sides doesn't exist in here, we need to just say sides, right? So that's good. That syntax token return, wait, what? Return random next in. Okay, we'll play with that just for a second. So now if I want to call that, and let's just make sure we don't have mynum. Okay, so we still need mynum. So we're going to declare mynum up here. So say int mynum, right? And we're going to say, we don't need to have it equal anything because we're definitely going to get it. So now anywhere we want it, what we can do now is we can call our thing. We can call our, oh, I didn't say public int. Yes, it's returning int. Okay. Sorry. It's really easy to get sidetracked while trying to teach things. So what we're going to do is we're going to say mynum equals, and we're going to call our function here, or our method. So here it's called roll dice. So we want to say roll dice, and how many sides do we want to roll? So if we want a 6-sided dice, we simply say 6. Is this right? Cannot make static. Oh, I might have to set this to static. We'll go over all this as static. That might be what I needed there. Okay, so here we're getting a random. Oh, and we also want to take our declaration in there too. Control X. Or we could just pass RND into it. Let's do that, because then we don't have to keep declaring that, I think. So if we also say, we're going to pass, let's see, we're just going to pass random, random, RND, oops, random. Although you have to do, you do have to spell it right. So now we're passing random in. We are RETURN. Yeah, that's right. Why is that? Public static int. That should actually work. I'm not sure why it's saying that. The method int rand. Oh, I haven't saved, so it doesn't know the next part, I think. Control S, maybe. So roll die. Oh, because we're also need to pass in random. RND. There we go. Now it's happy. I'm not exactly sure what's up with the return, though. RETURN. Okay, it's happy now. So let's say we wanted to do a 6-sided dice, right? Whoops. There we go. Later in our program, now we want to also do maybe a 12-sided dice. So we can copy that chunk of code, paste it. Let's just do a couple types of dice. So let's maybe do a 20-sided dice second. Let's do a four-sided dice third, and maybe eight-sided next. Sure, why not? So here are our type of dice. In fact, we could even, at the very end, we could have it flip a coin, right? We could say it's a two-sided dice. So if we hit run on this, we save and hit run. Now you'll see what this is doing is it's coming down, it's initializing our random, and it's initializing our num, and then here it's declaring, not initializing, it's declaring these, and here it's actually initializing it. It's saying num is going to equal whatever is returned from our method that we're passing a 6 and our random number generator. So then in here it simply says I'm going to return whatever this spits out. So I'm passing in sides here. So sides right here is set to 6. Therefore this is 6 and it returns a 6-sided dice. So as you can see, we have 6, 13, 4, 1, and 2. Right? So our 8-sided dice did that. Our 4-sided dice actually gave us our 4. But as you can see, each time we get different numbers. So I think now that you understand a little bit about how to get the random number, here's a homework assignment I want to give you. So I want you to create a program, not necessarily a program like this, but a program in flowchart pseudocode. I want you to create a program that will do the following. Let's write it down. Clear you. Okay. So what we want to do is we're going to call diagram, D-I-A, G-R-A-H-M. I want you to diagram a guess my number program. And I want you, so you'll use basically the same kind of concept that we did with our random there. It will actually, it doesn't have to be one that keeps going into a subroutine, but you can if you want, just to play with it, because it's not going to hurt. But you're going to have the computer, it's going to generate a random number. So here's your points. The comp will generate a RND number between 1 and whatever you want. Okay? So it's going to generate a random number. It's going to ask you, in fact, you could even have the computer at first, you could have the computer say, what is my number range? So you could actually say, okay, I don't want it to be, well, maybe we don't want to do that because we have to do something else with our random numbers and stuff. But let's just say what our range is. So 1 and 20 or whatever. You can even have the computer ask you first if you want. So this would be extra, I guess. Ask user for max num. So you can even have the user at the beginning say what they want it to be. So if they said, a number between 1 and 3, well, then it would generate a number between 1 and 3. So this definitely seems a lot like our little subroutine saying how many dice sides we want, right? Okay, so we want it to generate a random number. Then we want it to evaluate, evaluate whether the guess, evaluate, G-U-E, guess is, too high or too low. And we're going to have one of those loops in there. Remember last episode we talked about the do, the while, and the for loop. I'm going to recommend you do a do loop because you want to execute at least once. So You don't want to say, oh, do you want to play again or anything, or you don't want it to say too low before you enter in a number. So you're going to probably have a do loop. So this will be a little clue. Okay, and then finally, if they're right, you want it to end. So you want if, C-O-R-R-E-C, if correct, congratulate. Congratulate and if you want, once again, you can do a little extra credit and you could have it ask if you want to play again. Play again. So that's an extra credit thing. As is this guy, this is an extra credit too. Here, let's just erase this real quick. We'll make this one an extra credit also. So everything we talked about so far, you should be able to do this. It should be completely possible. So there's your homework if you want, if you choose to do it. In the next episode, we'll actually build this and we'll see how close what I do to what you do, see how close they are to each other. Now, just know that there is not necessarily a right or wrong. Just because I understand Java a little better than maybe you do, or understand the flowcharting concepts a little better than you do, doesn't mean that my answer is going to be the most efficient. Maybe you actually thought of something I didn't that's more efficient. So there you go, guys. I really hope you're enjoying this. If you are, be sure to leave a thumbs up down below. Aside from that, comment, like, subscribe. I already said that. Check out my other channels. My throat's a little dry, sorry. Check out my other channels. Check out my Discord. I'm on there every now and then. Maybe we can chat or anything like that. But that's it. Until next time, I'll be seeing you later. Bye.